Today we're talking Sapphire, not my birthstone, but an actual space station experiment that's going to be happening. We are here at Glenn Research Center in a high bay. Dr. David Urban has invited us in to talk about something called Sapphire. You're the principal investigator for Sapphire. Tell us what it is.
Sapphire is short for Safe Fire, and the purpose is to get an understanding of fire safety in spacecraft. Previously on Earth, all inhabited structures, be it a building, an airplane, a ship, or a car, we've done full-scale testing of the fire and how it grows. So we have an understanding of how to build vehicles and structures and how to defend against fires. In spacecraft, we've never had the opportunity to burn anything larger than approximately an index card. On the ground, we've had 2 seconds to 5 seconds of low-gravity testing. So we really don't know what the fate of a fire is. So our building of future spacecraft is based on 1G understanding and extrapolation from very small, short-duration experiments. So the goal is to burn a bigger sample, roughly half a meter by a meter, and we're going to have 3 flights of Sapphire. The first and the third flight will have a sample that's the full size of this card, and it'll be a cotton fiberglass blend like this material here. We'll ignite it from a hot wire like these, spread across the whole end, and it'll flow through the duct, and the flame will grow and spread down the sample, and we'll observe its growth rate and the final size of the fire.
So how do you go about asking someone, hey, can we start a fire on your spacecraft? How does that happen?
Not so easily. We tried for years trying to find a vehicle and a circumstance where this would work. And initially they'd get a not at my spacecraft reaction. But with some thought and some discussion, we established a way that we can still conduct the fire safely so it doesn't damage the spacecraft, but we can take advantage of the fact there's nobody there, so we can contaminate the air and raise the temperature slightly, but there's no damage to the vehicle.
So what size fire are we talking about?
It'll be half a meter by a meter. We expect it to be the flame to be about that long, and we don't know yet. That's the big question, is how big the flame will get.
Yeah, you think you may know the answer, but really we've never done anything like this before.
Exactly. So we can extrapolating from something this big to an order of magnitude larger is something we can only surmise at.
All right, well, let's take a look at the unit. So this is the actual flight hardware unit for Sapphire 1. Ross Miller, the external integration and operations lead here at Glenn for Sapphire 1, joins me now. And Ross, this is really a large unit to go on a rocket.
Yes, Lori, this is actually the largest payload that can fit inside a Cygnus vehicle. It just barely fits through the hatch.
So tell us what, other than the samples, is inside of here that makes this all work.
There are a number of sensors as well as our avionics computer, which commands and tells the sensors what to do. It also starts the igniter wire that actually starts the combustion of the sample.
So there are also fans inside of here because we need to keep this fire contained.
That's correct. There's fans as well as screens and filters on either side. So on the start, we have a screen and a flow straightener, and then on the tail end of the sample, we have a heat exchanger as well as a filter to make sure that any combusted products are contained inside this unit.
So the fire ignites. How do you get the data back? I mean, I think you've got, what, 4 to 8 days? It's kind of a quick turn to get this.
So the experiment runs over 20 minutes, and we're going to gather that information over a 20-minute period. There's a number of sensors that are in here that Joe will show you some of them on our ground development unit. All of that information is gathered and then compressed, and after that is done, we will then downlink that through ground stations, and that will take somewhere between 4 to 8 days to bring all of that information down.
I'm here now with Joe Poniuk, and I would say he's the brains of the operation. Joe, you developed the software that makes this all happen, right?
That's correct.
Tell us about that.
Well, the software will control the entire operation of the experiment. So it's actually pretty simple. The ground team just sends up a run command and automatically goes through the entire run sequence. The entire sequence is burning, collecting all the data, and then it goes into compression phase, and then it's up to the ground team to determine what data to downlink.
So there was lots of ground testing, and this is a ground
Correct.
development unit. Tell us about it.
Basically, we have the flight avionics in here. We have all the sensors, so we have some temperature sensors.
Oh, lights.
And we have LEDs, so we can record the char front as the fire progresses up through the samples. The difference we have with this sample card in here is we have some heaters on there to simulate some fire so we can test our airflow control. We need to maintain a constant airflow as the fire progresses, and the fire itself will cause a little blockage. It would slow down the airflow, so we need to speed up the fans to keep the airflow going. We We also need to keep the airflow going to keep the fire burning, otherwise the fire gets snuffed out. We have 2 cameras to record the whole thing. The sample card is too big for 1 camera, so we have 2 cameras recording the images. We have a carbon dioxide sensor or an oxygen sensor. Rather than the igniters, we have an igniter, a resistor bank here, so we can test out our software that controls the igniters.
All to get that valuable data down, and that's when your day gets a little busy and hectic, right?
It does get quite busy during operations, correct. Actually, during the burn, it's going to be kind of slow for us. We just sit there and watch the data. It's after the burn is done, trying to get all the data down that the science needs within the 4 to 5, 8 days. And anything else to say?
All right, well,
Okay.
that sounds like enough to me.
Okay.
You'll be very busy. We can't wait to see this.
Okay,
Thanks, Joe.
Okay, thank you.